Ready about 5C?
Yes.
5C, we introduced the idea of the vector product. Not the dot product, the vector product. Totally different to the dot product. The vector product is sometimes called the cross product. It's shown by A times B. The dot product is A dot B. The vector product gives you a vector as an answer. It doesn't give you a number like the dot product does. So, the vector product of A and B is denoted by A times B. The magnitude of the vector product, so the magnitude of A times B is the magnitude of A times the magnitude of B times the sine of theta, not the cos of theta like the dot product rule does. And just by some geometry that if we look at A and B, so there's vector A and there's vector B, this parallelogram that is formed, that is mapped by those two vectors, the magnitude of the cross product will give you that area. And it's just a little bit to do with the fact that this sine theta times magnitude of B will give you the height because of the right angle triangle, and you've got the base, so it ends up being the formula for a parallelogram. So if we're looking for the area of the rectangle, then the magnitude of the dot product will give it to you. The magnitude of the cross product will give it to you. The direction of the vector is perpendicular to the plane of A and B. The direction of the vector is perpendicular to the plane of A and B. The cross product will always provide a vector that is perpendicular to the plane of A and B. And we use the word cross product to be able to describe it. So the magnitude, we have a rule for magnitude. Magnitude of A, magnitude of B times the sine of theta. And there's that, the geometry of it happens to be the same as the parallelogram's area. So it's just a nice side aspect. We don't take the cross product to find that area, but we can use it to come up with that area. The direction of A times B, we can use our fingers. We point A towards the first vector, the index finger towards the first vector, the second finger towards the second vector, and the thumb will tell you the direction of the cross product. And it will be perpendicular to the other two. So, if this was A and this was B, my index finger goes in the direction of A, my second finger goes in the direction of B, and this here is the cross product which comes out of the wall towards me. Would that be correct? Yeah. If I then wanted to find the cross product of B times A, swap the order around, my index finger has to go in the direction of B, my second finger has to go in the direction of A, and can now you see your thumb going in the opposite direction?
Would it not give you the same thing?
No, you're going to get, in the first case, a vector going in this direction. The magnitude of it is the same. The components will be the same, except it will have an I that is a K component that is negative or positive. So that one's going up. That's your A and that's your B. How are we going so far?
Fantastic.
So this is the difference between A times B, index finger in the direction of A, B is the second finger, my cross product's going out of the wall, But if I do this one, my index finger goes where B is, and my second finger where A is, so my thumb's going towards the wall. So it changes the direction. The vector cross product of vector B times A has the same magnitude as A times B, but is in the opposite direction. We can see that B times A equals negative A times B. Thus, so we can't use these rules of multiplication or cross products because this cross product will be different to that cross product. If we have the vector product of parallel vectors, because the cross product equals the sign, and the sign of 0 is 0, therefore the vector product of parallel vectors will equal 0. The cross product of parallel vectors will equal 0. And that sort of makes sense as well, because if I've got A and I've got B, this is the answer, which is the area of that parallelogram. But if I've got A and I've got something that's parallel to A, I don't have a parallelogram to have an area of. Perpendicular vectors, the sine of 90 is 1, so perpendicular will give you magnitude of A times magnitude of B, if they are at right angles. If that is B and that is A and that's a right angle, then this is going to be the projection, and it's going to be the magnitude of A times the magnitude of B, the area of a rectangle.